London, 1928. A flurry of mold spores drifts into a laboratory on a gentle breeze. These spores land on a forgotten petri dish, sparking a breakthrough in medicine. The lab belongs to Alexander Fleming, a Scottish scientist studying bacteria. While Fleming is away on vacation, the petri dish with the mold is left unattended. When he returns, he discovers that a colony of mold has taken over the dish and has created a clear zone around itself where bacteria cannot grow. Intrigued by this oddity, Fleming investigates and discovers that the mold is releasing a substance that kills bacteria. This mold belongs to the Penicillium genus, and Fleming names the substance penicillin. What Fleming had uncovered was a natural defense mechanism. Penicillin is produced by the mold to protect itself from bacterial threats that might compete for resources. It works by attacking the cell walls of bacteria. These walls, made of sugars and amino acids, are crucial for bacterial strength. Penicillin interferes with the construction of these walls at a critical stage, preventing their repair. Additionally, it triggers the release of reactive molecules that further damage the bacteria. This double attack is fatal to many types of bacteria, whether they are in a petri dish, in our bodies, or elsewhere. However, it doesn't harm human cells because our cells lack cell walls. For about 10 years after Fleming's discovery, penicillin was mostly of interest to researchers. But during World War II, scientists figured out how to produce the mold on a larger scale and extract penicillin in significant quantities. Their work earned them the Nobel Prize. Both Oxford and American pharmaceutical companies advanced the development, making penicillin commercially available. This marked a revolution in infection treatment, and penicillin, along with similar antibiotics, became vital in saving countless lives. Yet, as antibiotics like penicillin become more widely used, bacteria begin to adapt and develop resistance. Some bacteria have evolved mechanisms to break down penicillin, rendering it ineffective. This growing resistance means it's crucial to use antibiotics judiciously and avoid overprescribing them. Additionally, about 5 to 15% of people in developed countries report being allergic to penicillin, making it the most commonly noted drug allergy. However, over 90% of these individuals may not actually be allergic. Often, a rash that appears after taking penicillin or similar drugs is mistakenly attributed to the antibiotic, when it might actually be related to the infection itself or a reaction between the infection and the drug. True penicillin allergies, where the immune system wrongly identifies penicillin as a threat, are rare but can be serious. If you suspect you might be allergic but are unsure, visiting an allergist is the best course of action. They can perform tests to determine whether you have a true allergy. Even if you are allergic, about 80% of people outgrow their penicillin allergy within 10 years. This is promising news for those who currently avoid penicillin. In the future, this life-saving drug might once again be a viable option for them, as it has been for so many others.